Thank you very much for watching this presentation. Do you have any questions? No questions?
Sorry, I seem to miss the presentation. What was it about?
Well, I just gave the presentation, so. In conclusion, React sucks, and it has very good ideas, so I respect it. But I do not respect Flux. It completely sucks. React is not reactive programming. Even though the name might say React, it has nothing to do with reactive programming. And it's also not good for reactive programming, and it could be better. And if you want other alternatives, there's like Mercury and Mithril and, well, I think I'm doing this presentation backwards. Sorry. Some kind of prank. Sorry. Very sorry. Yeah, okay. Okay, this slide is I'm supposed to talk about myself, but you don't care, and I don't care, so let's just go to the next slide. Why am I giving this presentation? Well, just think about Grunt, okay? Like, 2 years ago, it's like, yay, Grunt is so cool. And like, a lot of people using Grunt, and the idea is very good, right? Like, you use configuration for your build system and stuff. But then came Gulp, and like, Gulp is better and stuff, and then, you know, why not just use npm scripts? You know, it's more simple. So the point is that there's a reason why these things happen, and like, you know, it happens all the time in technology. Like, one does it one way, and then people find a better way. So don't believe like that there's a community around it, or that there's a hype, or even like Facebook around it. You know, Facebook makes quite a lot of crappy stuff. For instance, Facebook makes Facebook, you know? So, like, don't believe that. So, yeah. We're gonna talk how React could be better. And you're probably thinking, like, I don't even know React. Like, how am I supposed to, like, know all these stuff? How could it be better? But that's the point. Like, React is a bit too complicated to learn. And the question is here, like, how could React be simpler or easier to learn? Like why can't it just be, like, easier? Why does it have all these stuff to learn? And one way I can answer you is this library called Virtual DOM. Lift your hand if you have ever heard of this thing before. Oh, that's actually quite surprising. Okay, I didn't expect that answer. But anyway, you should try out this first because it's simpler, and it's also like lower level. So it doesn't get in your way. You can, of course, like send stuff from the child to the parent, and it's just like, you know, a lower level thing. And if you think about it, React was about the first one to introduce this idea of virtual DOM. And of course, like, pioneers make mistakes sometimes. So underscore came as like a functional library for arrays and stuff, and then like Lodash came. And if you're familiar, there's also Lambda. And so these things evolve. Like, why does the first one have to get it right? It's probably not like true that it's perfect. And what we're going to get into deeper here is the React authors don't seem to understand what reactive programming is, and they make some claims in their documentations, like there's reactive data flow, and I'm going to prove you that this is bullshit. And also they say like reactive state, and I'm going to prove you also that's bullshit, you know. And there's this word thrown around reactive, and a lot of people like to use it, but we're going to go into like what this thing is. So lift your hand also if you've ever heard of reactive programming. And yeah, so let's check what this actually means. Okay, so basically, if you're not excited about reactive programming, it's because you don't understand reactive programming yet. And this is like a holy thing, you know? And that's the definition of it. Well, basically, no. Like, if you take modules, like whatever files talking to each other, where, you know, an arrow means that A is influencing B, or A is sending data to B somehow. So in your typical case, you can see inside foo.js there would be some call like bar.setName, and that's how you typically see stuff. One question is, where does this arrow live in the whole code base, because everything lives in a module, right? Everything lives in a JS file. So where do these arrows live? Where were they defined? And is someone like courageous enough to give an answer? Okay. Well, yeah. Typically, you've seen the arrow defined at the arrow tail. So foo defines what are the other modules that it will change, right? So that's what foo did by calling bar.setName. And this is a pattern called interactive programming. So you've been doing interactive programming probably most of your programming career, where you've been like telling one module to, okay, go ahead and change that guy. And that's just how we've done stuff. Reactive is just the opposite of that. The arrow is defined at the arrow head. So instead of foo just changing bar, we just define we define bar to say that I want to get changes from foo. So bar defines which other modules affect bar. That's the idea behind reactive programming. It's just a concept, and one way of implementing this is by using events. So you can have some events inside foo, and foo just throws those to the public world, and then bar is interested in those events, so it catches those and says, okay, I'm interested in this, and I want this to change me. So that's one way of implementing this. And people have used like RxJS and Bacon.js for this pattern. I don't like bacon because I'm vegetarian, so I just prefer RxJS. Yeah. Now, what does how do you normally see programming in the interactive world? Is that you have kind of two roles. You have some module which is passive, so it just exposes functions like, for instance, I mentioned setName, that others will call it. And then you have some other module which is assuming the kind of proactive role, that he goes and like he's changing everyone. So there's these two roles in interactive programming, and you've been doing that quite a lot in your career. You've always been like exposing functions so others can change it. And the point here is that passive is a bad idea. And why is that? Because if you're exposing functions like setName, then that module is not responsible for itself. It's not responsible for its own changes, but it's instead of saying like, I don't care, someone else is going to take care of me. Someone else is going to change me. Like, that's it. So if you care about separation of concerns and like single responsibility and stuff, then you care about putting everything related to that module in that module. So let's take an example from real life. Like I am speaker.js and you guys are participants. So in the proactive and passive style of doing stuff, I would go and make a for loop. When I finish my speech, I go to the first participant and I say like, go get beer. And then I go to the next one, go get beer. And I go to the next one, go get beer, and I keep on doing this for loop. So I'm basically taking care of you, kind of like, when I end my speech, I will force you to do something. I will change you. And that sounds a bit retarded in real life, but it also sounds retarded in kind of like programming, because here, like, the speaker is having to, like, I don't care about you, you know? Like, I just want a speech. And then it needs to, like, be concerned about these participants. So in reactive programming, there's just one kind of role, which is the reactive role. And that means that the module listens to some events, it reacts to that, and it can expose some public events so other people can listen to that. And there's nothing else. There's just reactive. There's no passive, there's no proactive. It's just everything just reacts to each other. And the benefit here is that one module will be in full control over itself. It will say, like, I am interested in these events. So it's going to go like, you know, Lona's buffet and say like, well, I want this event, I want that event, and I want that event. And it's going to export other events. So if we think about, like, you know, participants and speaker, like, what was your name? Tommy? Tommy? Okay, so Tommy.js would would listen to my events of end of speech, and whenever that happens, he's going to go get beer. So he decides himself that, okay, I'm going to do my own thing. And then the next one? Consta.js will go like, okay, the speaker ended his speech, and when that happens, I'm going to tweet something, maybe. And that's the point. Like, each one can decide what they do, so there's no one like affecting you. Kind of, it's a very finished way of doing stuff. And what does this have to do with React? We're going to put things in place now. React is a bunch of stuff, and that's also a problem. It has virtual DOM rendering, which is one idea. You can actually make that a library. And then it has reusable hierarchical components like parent and child stuff. You can also make that another completely different concept. Like that, it also matches with web components, like custom elements. That's like reusable hierarchical components and has nothing to do with like virtual DOM rendering. Of course, you can make it. And then it hides the virtual DOM data structure from the programmer. So you don't have access to the data structure of the virtual DOM element. Like, you can't like get it or something. You just say render and bye-bye, you know. And then it has a mostly passive API, so you need to keep on changing stuff. And it's not a framework, it's a building block. So of course people mention like, what do I use for the models and stuff? Do I use Flux, do I use Backbone? So it's a building block only, it's not a framework. But it has this big opinion, like how you should do stuff. You can't put stuff like this and like that. So it gets in your way. And that's why people have been making like a bunch of like Fluxor and a bunch of, you know, things around it. Yeah. So this is proof of how React has all these different things inside it. It is proactive, passive, and reactive. The only thing reactive in React is that the render happens whenever state or props changes. So you don't need to say like, okay, state, change the state, and then, okay, render. Because the render happens whenever the state or props change. That's the only reactive thing. The passive things are these set states. So state is completely passive. The responsibility of the state is in the like app function. I mean the app code. So this kind of thing, whenever you see set, it's a passive role. And then this whole component is a proactive thing. This example was taken from like the front page React. Yeah. And so this whole thing is proactive because you're changing stuff a lot. So it's not really fundamentally reactive everywhere. And why is that a problem? The virtual elements inside React, they are not observable. You cannot extract them, as I said. So why is that a problem? Well, it avoids you from doing multiple things that you might want to do. For instance, testing is a bit worse because you have to put that component on the DOM and then test on the DOM. And testing on the DOM is not always the nicest thing because the DOM is a dangerous place to live. And it would be better if you could just get like model data, pass it through some function, get a virtual DOM element, and test that virtual DOM element. Does this have like that text and this kind of stuff? But you can't do that with React. It has to go down to the DOM, then you test on the DOM. And it's also slower if you need to use Phantom.js and stuff. And you cannot do something like this, like replace every foo with bar across the whole app, like through all the components. So you can't do post-processing steps, which is before the complete virtual DOM elements are put on the DOM. I want to do some processing, some post-processing on them. You can't do that because it's just not available for you as a programmer to catch them. And then, like, if you're using Bacon or RxJS, you can sometimes it's nice to do like, you know, this rendering will happen 1 second after the states and the props are changed. You can't really do that because it's as soon as you change the state, it's gonna render. So I don't know if you might want to do that, but you cannot do that. Then you cannot also reactively compose components because the way React works is that everything is hierarchical. So the parent owns its children. So in a different approach, you could have like completely separate components that are not owned by a common parent, and you could sort of join them in some fancy ways, and this is possible in other approaches. So how could it be better? Like, it's good to have these virtual DOM elements as first-class data structures, because you can test them and you can get rid of all those problems we just mentioned. And it's also better if it's reactive friendly, or it's better if it's just like friendly for anything else and it's just not opinionated. And as I said, like, there's some stuff hidden to the programmer. You don't have access to the virtual DOM element, so there's a lot of magic happening there, especially with the life cycle of the component. So there's a lot of magic happening there, and it might be a bit confusing for beginners. Virtual DOM, it's nice that you guys are familiar with it, is basically that. It's just the virtual DOM elements as data structures and the diff and patch algorithms. Diff and patch is like you have one virtual DOM element and another virtual DOM element. It sort of checks what changed, and the patch like change the DOM with exactly that specific change. So you can use this and you can put it in whatever kind of familiar way you like to program, and it's nice if you have some bit more control, and applying the diff and patches is like a one single line of code. It's not a problem to have it like in your app. Cycle.js is one framework I'm building that is a complete package of like model, view, and controller, and virtual DOM, and everything is reactive. So it answers like the Flux answer, so it's kind of like substitutes Flux. It's not a building block, it's a framework. And it's something I'm just experimenting with like virtual DOM, and trying to make a nice API around this. I'm gonna demo it a bit today. And one very nice thing is that everything is sort of functional. You don't have like idea of a class, and therefore you don't have this, like keyword this, you don't need to use it. Everything is just like input and output. And that has a lot of benefits, especially for testing. It's very, like the best way of testing something is if it's a function. So you just give an input, and especially a pure function that always gives the same output. That helps a lot for testing. Yeah, so the way Cycle works is that there's model, view, and intent. I sort of replace controller with intent, and they don't do the same things, because controller is like a proactive thing. So it's sort of assumed to change other guys, and that would be the proactive and passive pattern, and I don't want to do that. So what happens here is that the model, this is like what I think is sort of natural way of thinking of user interfaces, because when there are user interfaces, there's information in the computer, which is the model. So data and state and whatever. And then you want to see something from on the user interface, and that's the view. And then you want to interact with that. So you put some inputs there, and something needs to change with happen with that information that's inside the computer. So that's what I tried to model here. There's model, there's what you see, and there's what you change. And an interesting thing is that the render is separated here, because this will export virtual DOM elements as events. So it's going to say like, okay, this is an event where this is what is supposed to show in the DOM. But the view doesn't actually touch the DOM at all. It just has these virtual DOM elements. That's the role of the renderer, which is just to listen to those virtual DOM elements as events and put them in the DOM. So you could, for instance, replace this renderer with something else that doesn't touch the DOM, or like, let's say this touches like, I don't know, like, well, didn't get an example here, but you could make you could render strings, and you could send the strings to some backend service or something. The point being is that these are like, they're kind of like functions, but only in the sense that they have inputs and outputs. The view takes the model as input, and it exports virtual DOM elements as output, and also raw user inputs. And then the intent gets those raw user inputs and it sort of interprets what is the user trying to do. And then it exports those interpreted events as its public thing. And then the model is interested in those events. It kind of listens like, what is the user trying to do? And it changes its own data. That's sort of the basic idea behind it. This is one example, and you can probably see it's a bit big, but it's intentionally a bit bigger because you have everything sort of as a function. You don't have anything sort of, set state or anything changing anything else. Everything is like the view gets the model as an input, and it uses the sort of name event stream, just a event stream with the data of your name, and then it makes a virtual DOM element with that data, and it exports this as a v-tree. V-tree is like a virtual DOM element, and then that's the event stream. Then the intent will listen to those input texts from the input field, and it will just kind of interpret what is the user trying to do. And here we're saying that it's going to export events that are like called change name, so that the model can use it. So the model is observing that and saying like, whenever I see a change name event with a name attached to it, I'm going to make that my data. So it is a circular structure, kind of like Flux has. And down here there's a dependency injection system where we just say, we just plug these guys together. So we say, view, you're going to observe, hello view will observe hello model, and then hello intent will observe hello view. And I can show how this thing works. It's just a basic mapping from the input field to a H1 element. And yeah, I don't want to go so deep into this because it's not the point so much. But what's really nice is that each of these boxes is a data flow node. So the only thing it does is it gets inputs, events as inputs, and it exports events as outputs. So this is really data flow. React doesn't have data flow. And yeah, even though you read it on the docs, there's no data flow. Just because data goes from A to B doesn't mean it's data flow. You have to check from Wikipedia. And what's happening here is there's two pages. There's this page and there's that page. And then there's this middle thing here, which just manages like, what is the user trying to do? Like, is he trying to change pages? It listens to events from either page, and it defines then like what is the current page, and the page view just sort of gets from both of these pages their last like visual representation, and it decides like, okay, should I show this page or that page, and then that goes to the renderer. And what's really nice is that this is a mapping from the dependency injection part. So from here you can derive a graph that looks exactly, like a graph like this. Yeah. So this is what data flow really is. There's nothing else happening in the system other than events going from here to there. There are other approaches to virtual DOM. If you don't like reactive approach, then I recommend you try Mithril, which is impressively fast and also impressively simple, like compared to other stuff, like especially compared to React. It's basic model view controller with the virtual DOM, and it's also extremely fast. There are some very nice benchmarks, and yeah, so. Here the controller does change the model, and the model is like a passive thing. But I really recommend, if you're sort of confused with React, just check out Mithril or check out some other virtual DOM frameworks. They might be so much more simpler than learning React. And I think I've been to this before. Yeah. So in React, nothing is reactive except that rendering is reactive to the state and props. And React gives a lot of obstacles if you want to use it for reactive programming. And definitely, like, because they're the pioneers, it could be better, it could be simpler, and a lot of stuff could be sort of left out. The core idea in React is actually reusable components, and that is actually kind of the same idea as web components, so that's the idea. Thank you, and yeah, so yeah. Yes?
Have you used this model view intent architecture in any real project?
Yeah, like I used it in a customer project for like Sanoma, and it's working there. And it's also here, there's this small sort of web tool I made for learning RX, and it sort of applies also to Bacon, where you can just see how these operators work. It's like an interactive thing. And this is powered by model view and intent. Intent here takes care of like sort of getting raw inputs and like mouse down, mouse move, and mouse up, and sort of mapping that to what should change in the model. So it's a quite interesting implementation there. Any other question? Yeah?
It sounds like that in your model view intent pattern, those three elements are quite tightly coupled, and well, that's also the case quite often with the MVC pattern. And you mentioned that that it's a matter of opinion. You like your model better in a way that you think that that a module should contain the stuff that that it relates to. But kind of like, is there any kind of other benefits, like architectural benefits or something like that, by using the MVI pattern instead of the MVC pattern, or the reactive versus interactive?
Yeah, like you mentioned sort of coupling, and the coupling is just sort of like, at least in Psycho, it's just of what does the data flow node expect as input? Because you can actually substitute this view with whatever other view, as long as it will export the same kind of events as the previous view did. So they are much more replaceable, these blocks here, because they don't have functions which someone else calls. They just sort of have these properties, and it's much more pluggable, I've felt. And you can, for instance, put another block here between the view and renderer, and that would be like the post-processing step that I talked. You could just plug it in, as long as like the renderer doesn't really care what it's getting, because it just says like, I expect something that has these things as properties. So you can easily put something in between. You can easily put something in between model and view, and you can even, yeah, so just plug these things in. It's just that, like, think really of like actual plugs. It's just that they